Let's go on to electrons. Electrons are different from protons and neutrons because they're much, much smaller. Their weight is considered negligible when it comes to determining the atomic mass of an atom. Electrons also are very high energy. They are zipping around the nucleus at a great rate of speed with a lot of energy. In a neutral atom, the number of electrons is the same as the number of protons. Remember that protons have a positive charge and electrons have a negative charge. As long as you have the same number of protons as electrons, those positive and negative charges cancel each other out and you have a neutral atom. So we can determine the number of electrons in a neutral atom by looking at the atomic number. That tells us not only the number of protons in the atom, but also the number of electrons in the atom, as long as the atom is in a neutral state. The electrons exist in defined shells around the nucleus. This drawing shows us some of the predicted shapes of the shells of the electrons around the nucleus of an atom, but it's a little more complicated than we need to get into. We're going to consider that these shells of electrons are more like concentric circles or orbits around the nucleus. The first shell around the nucleus holds 2 electrons, so the first 2 electrons of any atom will go into that first or inner shell. The next shell, the second shell, can hold 8 electrons. So the first 2 go into the first shell, the next 8 go into the second shell, and then we put 8 more in the third shell. After that, we put more electrons into the fourth shell. It does get a little more complicated from there, but for our purposes, we can work with just those numbers in the first few shells. 2 electrons in the first shell, 8 in the second, 8 in the third, and then more into the fourth. The reason these shells are important is because atoms like to have full shells of electrons. If you have a full shell, that makes the atom more stable. So for example, helium has 2 electrons. Those 2 electrons go into the first shell. Electron has a full outer shell of electrons, and it's nice and stable. Neon has 10 electrons. The first 2 go in the first shell, the next 8 go in the next shell. That gives it a full outer shell, and neon is a nice and stable atom as well. Argon, with 18 electrons, is also nice and stable. 2 electrons in the first shell, 8 electrons in the second, and the remaining 8 go in the third shell, so all full shells of electrons and a nice stable atom. We can find these happy stable atoms that have full shells of electrons all the way over at the right-hand side of the periodic table, and we call these the noble gases. They aren't of much interest to us because they are so stable. They don't interact with other atoms, and so they don't help form molecules, which we need to build living things. So we're going to leave those aside for now. The other atoms don't have full shells of electrons when they're in their neutral state. Let's take a look at something like lithium with 3 electrons. 2 go in the inner shell, 1 goes in the second shell. That second shell is not a full shell, so lithium is not a stable atom in its neutral form. The same is true of, say, oxygen. With 8 electrons, 2 go in the inner shell, and the remaining 6 go in the second shell. That's not a full shell either. It could take 8 and it only has 6. So that makes oxygen an unstable atom in its neutral form. So what's an atom to do if it wants to be stable? Well, atoms will take electrons from other sources, or give away electrons, or share electrons as needed in order to get full shells. And it's that taking and giving or sharing of electrons that allows atoms to be able to form bonds with each other so that we can make molecules. The term for an atom that either took or gave away an electron in order to become stable is an ion. And ions are charged because originally they had the same number of electrons as protons, making them neutral and having no charge. But if you have an atom that gives away an electron, so it had the same number of electrons as protons and then it gives away an electron, it has more protons than electrons. It has a positive charge. If you have an atom that takes an electron, then it has more electrons than neutrons, and that gives that atom a negative charge. Let's look a little bit closer at what might make an atom give away an electron. If we take a look at the atoms that are over on the left-hand side of the periodic table, all the way over here in group 1. These atoms only have one electron in their outer shell. Something like lithium has one electron in the second shell, and that's all. If we go down to sodium, sodium has 2 electrons in the first shell, 8 electrons in the second shell, and only 1 electron in the third shell. When an atom has only one lone electron in its outer shell, it's really easy for it to just get rid of that electron, just give it away, in order to become stable, to have full shells of electrons. So these atoms on this side of the periodic table will tend to give away an electron, and that will give them a positive charge. You can think of it as giving is a positive thing to do. Positive ions are called cations. Many of the atoms here in the second group of the periodic table are also likely to become cations, and that's because they only have 2 electrons in their outer shell, and sometimes it's easy to give away those 2 electrons in order to be more stable and have a full outer shell. So they also can form cations. Over on the other end of the periodic table is where we find the atoms that are more likely to become negatively charged ions, or anions. And that's because these are the atoms that have almost full shells of electrons. They're so close to having full shells, they just need to steal another one in order to have a full shell of electrons and be stable. Something like fluorine. Fluorine, if it were neutral, has 9 electrons, that's 2 in the inner shell, and 7 in the second shell. It's only 1 electron short of having a full shell. So it will take an electron from somewhere else and become a negatively charged anion. It has a charge, but it has a stable number of electrons.